Physics is the study of matter, energy, and the interaction between them.
A branch of physics is thermodynamics. Thermodynamics is a system that interacts and exchanges energy with the area around it.
There are two main laws that govern thermodynamics. The first law states that whenever heat is added into a system, some of the heat stays in the system and some leaves. The energy that leaves a system does work on the area around it. Whatever energy that stays in the system increases the internal energy of the system.
For example, water at room temperature. If you add heat into the system, the temperature and energy of the water will increase and will release some energy into the atmosphere, such as steam.
The second law also states that it is impossible to have a process that converts heat completely into work. Work is energy that is transferred. It is also impossible to have a process that transfers heat from cool objects into warm objects without the use of work. The second part of the second law states that a cold body cannot heat a warm body. Heat naturally wants to flow from warmer areas to cooler areas. In short, it measures the amount of entropy, which is chaos.
For example, when ice is put in tea, entropy will increase and the ice will melt rather than the water molecules uniting back into ice.
Like we said before, the energy in transfer needed to happen in at least one of two ways. At least one of the ways must be a transfer of heat. If the thermodynamic system is in equilibrium, it can't change the state without interacting with its system.
Simply put, if you're in equilibrium, you're a happy system, just minding your own business and you can't really do anything. If you're in disequilibrium, you have to interact with the world around you. Thermodynamics is useful because it helps us connect the world of many small atoms to the large-scale world we can see.
There are many real-world uses of thermodynamics. Earlier, it was used to study the makings of steam engines and how they can work better. Nowadays, ideas from thermodynamics are used in everything, from making engines to studying black holes.
Thermodynamics can be used to make engines and refrigerators. It also helps us to understand the properties of everyday materials. It is also used in chemistry to explain which reactions will and will not work. Thermodynamics is powerful because simple models for atoms work well in explaining the properties of a large system, like bricks.
A brick is made up of many atoms, which all have their own properties. All thermodynamic systems have two kinds of properties, extensive and intensive.
For the brick, the extensive properties are ones you get by adding up all the atoms. Things like volume, mass, energy, and charge are extensive because two of the same bricks put together have twice as much mass as one brick.
The intensive properties of the brick are the ones that you get by looking at the average overall atoms. Things like temperature, density, and pressure are intensive because two of the same bricks still have the same temperature as one brick alone.
This concludes our presentation on thermodynamics. I hope you enjoyed it.